Now, notice again we have simply sine of x is less than or equal to the cosine of x, and it's an inequality. Let's try to approach this problem from the point of view of the graph, shall we? And I've already made the graph. We know this is our sine curve between 0 and 2 pi, and there is our cosine curve between 0 and 2 pi. Now, let's just look at the sentence. Sine of x is this height, wherever it happens to be, and the cosine of x is the height of the dotted line. Now, where is the height of the sine curve less than or equal to the height of the cosine curve? Okay? So you look at it, and you just read it from the picture. And so where is the solid line below the dotted line? And you say, well, it's below it here up to this number, which is what value? At pi over 4. So indeed, the values of x, which will make this true, will include the origin and this point and everything in between. Everyone agree with that? And now let's see, where else is the solid line below the dotted line? And you look over here, and it will start right here. They will intersect again at what value? 5 pi over 4. That point must be included. And in fact, from there all the way over to 2 pi. So those points on that section of the segment of the line must also be in the solution set. Well, if we wrote this as a solution set, let's say that the set of all x is such that, and what? X then is what? Greater than or equal to 0 and less than or equal to pi over 4. And what word must we use? Or. And we now have what? X must be greater than or equal to 5 pi over 4 and less than or equal to 2 pi. And that then would be the solution set of this original sentence. Okay? Let's look at a last example. Here we have solve for x, in which it's the inverse cosine of 2x is equal to pi over 3 minus the inverse cosine of x. Now, it's somewhat similar to the other one, but perhaps a bit more complicated. And again, just looking at it, what would you like to do to both sides in order to try to undo that inverse cosine? And what do you think? Doug? Take the cosine. All right, let's take the cosine of both sides. So the cosine of the inverse cosine of 2x is equal to, and on the right side, notice we have the cosine of, we have there what? Pi over 3 minus the inverse cosine of x. Now, the left side, the cosine of the inverse cosine of 2x is equal to 2x. So therefore, we have 2x is equal to. Now, notice here, we have the cosine. Think of this as the cosine of a minus b. All right? Now, the cosine of a, our formula says that this must be what? The cosine of pi over 3 times the cosine of the inverse cosine of x. Is that right? And then it's what? Plus what? The sine of pi over 3 times the sine of the inverse cosine of x. Well, let's just continue with this. What's the cosine of pi over 3? We know that it is what? That's a half. 1/2 times, and the cosine of the inverse cosine of x is x plus, and now the sine of pi over 3, you know, is root 3 over 2 times, and now here we have the sine of the inverse cosine of x. And I think you might be stuck. Now let's go to a picture. Let me decide to call some angle A here. The cosine of, the inverse cosine of x is that number A, such that the cosine of A is equal to x. Does everyone agree that that's what we have in this picture? Now look at that picture and give me a name for this side right here, this height, in terms of 1 and x. And what do you see there? Brenda?
1 minus x squared.
1 minus x squared. Not quite, but
The square root of 1
the
minus.
square root of 1 minus x squared. Does everyone agree with that? Now, look at that. You're interested in the sine of A. You're interested in the sine of A. So what then is the sine of A equal to in terms of your picture? And it's equal to what? The square root of 1 minus x squared over 1, which is simply the square root of 1 minus x squared. Okay? Now we have this equation in terms of x, and let's see if we can't solve it. Well, let's multiply both sides by 2. We have 4x then is equal to what? X plus the square root of 3 times the square root of 1 minus x squared. And you can subtract x from both sides. 3x then is the square root of 3 times the square root of 1 minus x squared. What now do you think you'd like to do to both sides?
Square.
Square them. Now, as soon as you square them, you have lost equivalency. Is that right? Because when you undo that, you might get plus or minus. So if we then were to square this number, we get 9x squared is equal to, and here we have, what, 3 times this number, which is 1 minus x squared. Well, if you simplify that, we have 3 minus of 3x squared. Let's add 3x squared to both sides. 12x squared is 3. X squared then is 3/12, which is 1/4. Now, if x squared is 1/4, therefore x must be what? 1/2, or x must be negative 1/2. And here is a case where I believe we need to check. Now let me write down the original equation, which is the inverse cosine of 2x is equal to pi over 3 minus the inverse cosine of x, okay? Now let's just substitute 1/2. Well, if x is 1/2, 2 times 1/2 is 1. The inverse cosine of 1 over the domain of the inverse cosine function, you know, must be equal to what number? The inverse cosine of 1. Careful. It must be 0. As a matter of fact, I've made a picture of the graph of the inverse cosine of x. Now, when x is 1, what then is the value of the function? But right here, 0. Is that right? So indeed, the inverse cosine of 1, you know, is 0. The question is, do we get 0 on the right-hand side? Well, we have there pi over 3 minus. Now, the inverse cosine of 1/2 is what we're substituting. And when we substitute x as 1/2, that's this value here. And what then is the value on the curve for the inverse cosine of 1/2? And it's pi over 3. So sure enough, pi over 3 minus pi over 3 is 0, and that value checks. Now let's then check the other case, in which x is negative 1/2. Well, 2 times negative 1/2, of course, is negative 1. The inverse cosine of negative 1. Well, let's look at our graph. Here is negative 1. What is its inverse cosine value? But up at pi. Is that right? It's at pi. So the left side is pi. The question is this equal to? The right side, we have pi over 3 minus. Now here we're interested in the inverse cosine of negative 1/2. Well, looking at our graph, negative 1/2 is here, and its value for the inverse cosine function is what number? 2 pi over 3. So pi over 3 minus 2 pi over 3. The question is that equal to pi? And of course the answer is no, and this is not true. Therefore, what must our solution set be? 1/2. And it's simply the one number, 1/2. Okay? And that then is the solution set. Now let me give you your homework assignment in which you can do some of these problems on equations. And this is assignment